Third type of domain algebraically we're going to be talking about are working with radical functions, specifically square roots, cube roots, fourth roots, fifth roots of some polynomial. So I'm going to kind of classify these in two categories. We have square root, since square is to the second power. Square root would basically be like a 1/2 power kind of thing. We're dealing with even roots, so square root, fourth root, or I'm going to classify as even roots, and then odd roots are going to fall into its own separate category. Cube root, fifth root, seventh root, those are all going to be the same results. When it comes to radicals, square roots, and fourth roots, we cannot take a number times itself twice, two factors of a number, and get a negative. Similarly, we can't take something times itself four times, four factors of it, and get a negative. So therefore, the part inside, whatever you're taking the square root of or the fourth root of, can't be negative. Well, sometimes it's hard to say something can't be negative and do that mathematically. So instead, if x can't be negative, if this quantity right here can't be negative, then what it can be, sometimes it's easier to look at the other end of the spectrum. What it can be is positive or zero. So therefore 2x minus 5, whatever's inside, you set greater than or equal to 0 and you solve. And in this case, remember, if you multiply or divide by a negative, you flip the symbols. In this case, we're going to add 5 and divide by 2. We're not multiplying or dividing by a negative. So x greater than or equal to 5 halves. So that means if we're thinking on a number line, so basically that's your domain right there. So on a number line, x greater than or equal to 5 halves would be like that. Okay, so our domain is from 5 halves to infinity. And that is it, ladies and gentlemen. Radical function, simplest case. I'm going to go ahead and flip down to the fourth root. Since a fourth root, a number times itself, four factors of it, to get x plus 5, basically, the fourth root of x plus 5, we know that part can't be negative either because you can't take number times itself four times and get negative. So similarly, on a fourth root, a sixth root, an eighth root, you're going to say x plus 5 has to be greater than or equal to 0, so x has to be greater than or equal to negative 5. And very simply, your domain is from negative 5 to infinity. And we are completely done with those two. Finally, cube roots, fifth roots. I can take a number times itself, three factors of it, number times itself again, and get a negative. So therefore, cube roots, fifth roots, seventh roots, I can take negatives or positives. When I actually look at the graphs of those, they look kind of like this. They go infinitely both directions. So therefore, for cube roots, fifth roots, seventh roots, all odd roots, the domain is from negative infinity to infinity, or we talked about in the first one, that would be all real numbers. And that's the domain of radical functions, simplest form in a nutshell.